Welcome to the AWS Summit Online. My name is Richard Boyd, and I'm a Senior Developer Advocate with Amazon Web Services. Today, we're going to be covering GitOps, managing infrastructure on AWS. Our agenda is that we're going to start with what is GitOps and how it relates to cloud infrastructure. We'll give an overview of what is infrastructure as code. Then we'll talk about why customers use GitOps to manage infrastructure as code on AWS. And finally, we'll talk about some AWS solutions that enable GitOps. GitOps is needed because teams are becoming more distributed, and the lines between an application and infrastructure code are becoming more and more blurry. And because of this, and infrastructure as code as a capability, teams can provision and build infrastructure in just a few clicks. It's never been easier. But infrastructure as code brings about a new set of challenges related to managing this application code and infrastructure code in a collaborative way. Some of the common problems for managing infrastructure at scale are around automation, consistency, and versioning. This democratization is made possible with tools like CloudFormation and CDK, which have eased the creation of infrastructure as code. However, now that it's easier to create this infrastructure, we also need a way to manage it. So the first problem is related to automation. When you want to build or provision infrastructure in the cloud, the easiest way to get started is manually via the AWS Management Console. All right, you log in. It's generally one of the first pages you see when you start your cloud journey. It has a nice graphical user interface. It works with all these modern browsers. But some of the downsides to that is that it's not as reproducible. If you go through and you click a few spots to create, say, an S3 bucket, or if you want to create a DynamoDB table, even if you take diligent notes about what you did and how you did it, and then you hand that off to someone else who wants to do something later in 6 months or 12 months or a year, perhaps the console has changed, new features may have been added, some features may have been moved around within the console, and someone else might not be able to reproduce what it is that you did previously. It's also potentially error prone. As much as we like to make the console as accessible as possible, there's the possibility of a typo as you're typing in a bucket name, or setting the provisioned read capacity units on a table, and you accidentally add a 0 to the end, or don't add enough zeros to the end and over or underscale it. And it's time consuming. Trying to make many copies of the same resource for different parts of your application can take a long time. And that's time that you'd rather spend doing something along the core business lines. So the next logical step that teams take from there is that they move to a scripted approach. They use the AWS CLI or the SDKs, and they will automate the actions that a person did in the console. But then you end up having to think about, okay, what happens if an API call fails? How do you retry it? How do you check to make sure your retry strategy is appropriate, that it's working correctly? How do you update it? Once you've created your infrastructure via some script, are you going to have to create a brand new script to update it to get it from that state to whatever some new state is you might need in some time in the future? And then you get into some more kind of meta questions about this automation. Is like, how do you know if your resources are actually ready to use? You could poll them. Some resources emit a state saying it's ready, the resource is ready. Some just say, okay, well, if you have access to it, it's implicitly ready. Or if you make a change, like how do you undo it? Let's say you created 3 buckets, you meant to create 2. How do you kind of roll back that change? Or if you make an update to a Lambda function and you decide you want to roll back that change, you'd have to write custom scripting just to handle that. So the next approach teams graduate to after that is resource provisioning engines. These are things like AWS CloudFormation. They make it easy to automate. They're reproducible. You get a custom domain-specific configuration syntax, but there's no abstraction in this. You have to fully specify all of the details for the stuff that you're building, and it becomes very verbose. And it's also used for automating disaster recovery to copy a configuration from one area to another without having to spend hours or days or weeks manually rebuilding a new environment after a disaster. So this is the first issue of automation that addresses the the management of infrastructure as code. By using resource provisioning engines, it automates a lot of these processes we see with the manual approach and the scripted approach to infrastructure as code, infrastructure provisioning. The next issue that needs to be addressed is consistency. You want to know what is the source of truth for how your application is supposed to look. If you're using the manual approach in the console, someone might just tell a person on the team, hey, create an S3 bucket and use these values. And that person can either keeps it in their head or maybe they write it down and they go to the console and they attempt to enact this change. And next week or 2 weeks later or a month later, someone says, hey, what were the settings that you needed to use? Maybe the person will go back to the console and say, well, here are the settings that are actually used, but it might not have been what they were actually told. So maybe they'll go to their notes and say, well, here are the notes I took of what I tried to do. And somebody else will have to go and kind of reconcile those two. But by using infrastructure as code, you can say, here is a full description of the application, of the infrastructure that we want to use, and hand it to a resource provisioning engine and say, provision this infrastructure. And when that happens, it's easy to look at the infrastructure as code file and say, here is what I wanted to build. And then you can look at the state of the system as it exists and say, here is what exists today. And there's a tool we'll talk about, drift detection, that tells you, are these different? Has the way the system exists today drifted from how I described it a few weeks ago, or a month ago, or whenever I provision this? And this is helpful in either debugging or triaging issues that might be popping up or appear to be popping up. One of the first things people check is drift. Is the system not in the state that I thought it was in? Because then it's possible to simply redeploy the CloudFormation template and put the system back in the state that you expect it to. And oftentimes that's enough to remediate application level issues. And then finally we get to versioning. Versioning tells you what state the system is in over time. When you first start your application, when you first launch your application, you might have a couple of Lambda functions, a single DynamoDB table, and an S3 bucket. But over time, you're going to add more functions, more tables, more buckets. And you may want to look back and say, well, what did our system look like 6 months ago? What did it look like last year or 2 years ago? Or if you're deploying and you make a change, you say, hey, let's just put it back the way it was yesterday before this issue started. By using a version control system, such as Git, you're allowed to track exactly who made what change and when. And often via a pull request workflow, you can understand why they made the change, and you can have other people on the team verify that change was made correctly, which can't really be done in some of these more automated or scripted approaches. So this introduces this idea of GitOps. As a motivating example for the value of GitOps, we'll look at Heartbleed, which is this vulnerability in TLS, transport layer security, that happened about 7 years ago. And the issue was it was a commit that was made to the core library. There was a bug, I believe it was related to somebody said, here's a keep alive message called Heartbeat. And oh, by the way, I need 10 kilobytes of a response, or the size of this message is 10 kilobytes. And the system would use that to say, okay, here's your response. I'm going to send your message back to you. You told me it was 10 kilobytes. Here's 10 kilobytes. But there was nothing keeping the person from saying, oh yeah, this message is 200 kilobytes, when the message was actually only 10. And what the server would do is it would return the 10 kilobytes of the message plus another 190 or however many were specified of arbitrary memory on the machine, which could potentially leak private keys or sensitive data. It was a very serious bug that was fixed very quickly once it was identified, but it swept the nation, is the idiom people use in terms of everyone was talking about it. And because TLS is used so broadly, it was an open source library, this change had to be made for the patch for this across millions of devices. And if you're using a GitOps solution, you can very easily search through your code base. Almost all Git providers provide the ability to search the code and look for dependencies on this vulnerable version of TLS, and then replace that, bump the version, and then check in that code, and then it'll go through your deployment pipelines and out to your fleet of hosts. So you wouldn't have to individually go to each affected host and make a change to each one and hope that you got them all. And because you're using this automated pipeline, you can easily roll it back if you realize that perhaps the update broke some other dependency that particular fleet or part of your application would need to either wait, or you can need other mechanisms to fix those. And finally, you can do automated testing. So you're not going to want to just say, okay, here's the patch, put it in production right away. You're going to say, okay, here's the patch. Now run our regular suite of automated unit tests to make sure that, one, it fixes the issue, but also it doesn't break the rest of the application in the process of fixing the issue. So we'll talk about how GitOps supports this use case. All right. So GitOps is an approach where infrastructure is defined as code, often abbreviated as IAC, or infrastructure as code, alongside application code. It's versioned in a Git repository, and it's provisioned following the same merge request process as application software code. So your infrastructure as code, it's hosted just like the application software code that you have. You can reuse the existing application management tools if you use linters for checking your code, if you have specific Git workflows that you use for tracking versions, for tagging versions, for pull requests, processes for notifying people that a change needs to be reviewed. Oftentimes teams will have meetings or SLAs set around ensuring that pull requests are reviewed in a timely manner on their team. And then finally, you can reuse your existing CI/CD mechanisms for your automated build, test, and deploy. So you can run linters, static analysis checks against your infrastructure as code to make sure that it's complying with the company's best practices related to infrastructure. Perhaps you're in a company that doesn't want S3 buckets being created that are open to the world, or public S3 buckets. It's a common use case that most companies want to lock down. Or you want to ensure that every item in there is encrypted with a specific key. You can have an automated build or test action that will verify that that's true, which isn't a capability you would be able to easily do in a more manual approach, not using GitOps. And GitOps makes managing infrastructure as code easier. And the end result is that you have a consistent version and the automated way of provisioning and managing your infrastructure as code. And we've seen companies like Deloitte, Expedia, and Coinbase leverage the AWS offerings in the GitOps space related to code pipeline and code build, CloudFormation, code deploy for moving much more quickly to release features, provisioning infrastructure, and spending more time on their core business. So a sample walkthrough of how a GitOps workflow would look is that you've got some single source of truth that is a CloudFormation template that defines your entire infrastructure stack. That could be multiple stacks as like a stack set to deploy to many accounts if you wanted to use those to reduce the blast radius for an account. An outage or an issue with a single account, you might use that for tenant isolation if you're running a multi-tenant SaaS application. And the GitOps workflow will test and evaluate and build CloudFormation templates and then deploy those. It will track what's the status of this deployment. It'll roll it back if there's a failure to the last known good state. So if there's a typo that slips through your linter, or you try to specify some IAM permission that you don't have access to, it will recognize this as a failure, and it will roll back the infrastructure deployment to the last known good state. And all this means that your infrastructure is defined and built and run through a CI/CD process. And then at any point, you can look at your infrastructure as it exists and compare it to the template that you are using for defining your infrastructure, and perform drift detection to say, has something changed? Did someone go into the console and manually change a setting that they should have done through infrastructure as code? Did something auto scale so that it's no longer conforming to the scaling parameters I'd already defined previously? Maybe that's why, maybe they scale it down too much and the CPU load is increased, or things like this. So that's why drift detection is often a first stop people look at when debugging performance issues within their application. Right. And this allows us to bring DevOps practices to infrastructure. Because we can treat our infrastructure code the same way we do our application code, we can reuse a lot of the benefits that we get from DevOps, which means that the change management tools are 3 times more effective. We see that the time required to restore a service after an incident is greatly reduced. We see 77% of teams able to restore their service after an incident in under a day. And then finally, we also see that 60% of teams are able to remediate a vulnerability that was identified, such as that Heartblade incident, in less than a day as well. So these are values, these are benefits that DevOps has brought to application code that we've known about for years. People have a deep corpus of knowledge and expertise in applying DevOps to application code. And with infrastructure as code, we can apply those same practices and get those same benefits in our infrastructure definitions. So we'll walk through an example of like how this process is deployed, how it works in a typical developer's daily work. So first, the developer will write some code, either web-based IDE such as AWS Cloud9, or locally on their machine using the AWS Toolkit for VS Code. They'll author a CloudFormation template, and they will commit it to a branch in a repository that they share with their team. They'll create a pull request to pull that branch into the main branch and have someone else on their team review it. You can set rules saying in order to merge into main, you need at least 2 people from this group, or you need at least one other person who isn't the person who created the pull request from this group. And then once all the approval rules are satisfied, it will be picked up by AWS Code Pipeline, which executes your CI/CD test and deployment actions. So this will run things such as CloudFormation lint, which is a linter that checks for syntactic rules that you define, CFN guard, which I mentioned previously, ensure that you're using best practices. And finally, once it passes all these checks, it builds, it appears correct, you can start the deployment process, and it will deploy it to maybe 1 account at first, and then 2, and then 3, and then 5, and scale out to all of your accounts where this infrastructure is needed using CloudFormation. And if it encounters an issue in any one of those accounts, it'll roll back that account and then stop the pipeline and say, hey, there was an issue here that needs to be fixed. Here's the error. And it allows the developers a chance to correct that error and then continue the deployment where it left off. So within AWS, we have Code Commit as the GitOps solution. We've got multiple infrastructure as code options that accommodate different ways developers want to build. So we have CloudFormation for developers who want to use JSON and YAML, who prefer that very clear, explicit, declarative infrastructure as code. We have the Cloud Development Kit, which is a way of writing infrastructure as code in a language that developers might already know, such as Python or TypeScript or Java. And we have the AWS Serverless Application Model, which is an extension to CloudFormation that specializes in defining serverless applications, specifically applications that use or rely heavily on AWS Lambda. And then finally, we have the CI/CD solutions. So we've already mentioned Code Pipeline, and Code Build is the build action that will perform like the CFN lint and CFN guard, and do your computational checks, static analysis that need to be done. Integration with like third-party tools such as Snyk or WhiteSource for checking to make sure that you're not taking dependencies on vulnerable software. And then finally, there's tools like Code Deploy, which actually deploys your application code to the target accounts where you want to deploy it. So we dive a little bit more into like the specifics of CloudFormation. It's this tool for infrastructure as code in the enterprise. It's a declarative JSON YAML-based template to describe the infrastructure, and it automates provisioning infrastructure as described in the template. Makes it easy to scale this infrastructure. If you want to, you had 1 bucket and now you want 30, just copy and paste the bucket as many times as you need, making the small changes you need along the way. It has tooling and integrations for enterprise requirements around compliance and governance and automation and security. Like I mentioned before, there's CFN guard, CFN lint, CFN nag. And then there's also third-party tools that can be used with CloudFormation via the resource registry, which up until early 2020 was a private registry. You could publish resources and third-party resources in this registry privately within your account. After early 2021, after early 2021, when we announced the public registry, third-party providers or companies can publish their resources publicly if they want and say, anyone can use this thing that I built for integration with CloudFormation so that it brings infrastructure as code to more than just AWS resources. And the AWS Cloud Developer Kit, CDK, is a tool that sits on top of CloudFormation. It takes programming language that you already know. In this example, it is TypeScript, and it compiles that down to CloudFormation, so you can represent your infrastructure code in a language that you're familiar with. You might already have tools built for doing, linting and syntax checking, and other types of Python has like PEP8 for ensuring that the syntax is correct or it's formatted properly. It allows you to create very powerful abstractions, so you can encapsulate multiple pieces of infrastructure into one logical entity. We see inside CDK itself there is this what's called a Lambda REST API. So it's a API gateway REST API and a Lambda function, all wrapped up together into one resource as just a web API that someone can define just a few default properties for and just deploy it in just like a few lines of code. Whereas if they were using the lower level CloudFormation syntax, JSON YAML syntax, it would be a few hundred lines. And this supports Python, JavaScript, TypeScript, Java, C#, and we currently, as of mid-2021, have Go in developer preview. Right. So if we go into how CDK works, there are stacks and constructs inside of the source code, and those are executed by the AWS CDK CLI, which synthesizes those into a CloudFormation template and a set of assets. Then those assets are deployed, the templates and assets are deployed to CloudFormation, which is provisioned by the CloudFormation service to create cloud resources. And this allows you to use a single set of tools, namely CloudFormation and the tools built on top of that, to satisfy needs for almost any organization. So you've got tools like CDK and SAM that are targeted at being developer focused. They increase developer productivity. They are more ergonomic for developers to use. And then things like the CloudFormation YAML syntax and the CloudFormation service, which are more operator focused. And those are the specifics of, how do I manage this infrastructure? How do I manage the provisioning of this infrastructure and define security boundaries around it to say who can or can't deploy infrastructure, what kind of infrastructure can or can't deploy. So using the same set of tools, different parts are focused on either the developers or operators. And then when taken together, they're extremely flexible and powerful. And this is another example of the workflow that's used for CI/CD in general on AWS. So if you look at this and you replace the CloudFormation template on the left and the template stuff on the right with application code, you see that you could use the same workflow, whether it's application code or in this example, infrastructure code, which is a CloudFormation template, which if you have one tool, one process for deploying both of these, you don't have to worry about developers needing to understand or become fluent in multiple processes, whether they're deploying application code or infrastructure code. And you don't have to worry about someone only specializing in one and not understanding how to do two of those. By having a single set of tools, it allows developers to spend more time and more mental energy on your core line of business. And coming back to the consistency, scalability, visibility issues that we mentioned earlier, that CloudFormation solves these through eliminating out-of-band changes with the drift detection, creating visibility through versioning, through Git source control versioning of the template that's deployed into CloudFormation, and then scaling through automated provisioning. So if you need to deploy 10 copies or 1,000 copies of some application, you don't have to worry about finding 10 or 1,000 people that will do this work. You can just send the same template tens or hundreds of thousands of times to the service, which will automatically provision the infrastructure for you. So it scales on your behalf. And some of the additional benefits it has, it creates compliance with industries that might be in a highly regulated industry, or security through things like CFN Guard, CFN NAG. With CDK, you can help developers build more securely by default, and simplifies the compliance process. It has native integrations with other AWS tools and services. And then, as I mentioned previously, there's a CloudFormation registry, which has both public and private resource types from the AWS Partner Network, developer community. Your own team might publish their own private resources or public resources as part of an open source initiative. And you can reuse a lot of these same resource types that are created by others. And finally, AWS enables customers to define, provision, and manage infrastructure as code with GitOps using CloudFormation and tools like the AWS CDK, Code Pipeline, Code Commit, Code Build. With that, I'd like to thank you for attending my session today. If you have any questions, you can reach me at the email address that's listed. And finally, there will be a survey for this session. Feel free to fill that out with any feedback about this session, about what you'd like to see in future sessions, or about ways we can make this session better. Thank you.